Hello everyone, welcome back to our RF knowledge sharing video. My name is Chi and I'm the RF engineer from iVision Australia. So today we are going to talk about something really exciting, the RF testing for OTA testing for 5G. You know that 5G is definitely the hottest topic recently. And why we need to do the OTA testing, over the air testing, on 5G rather than 4G. You know that for LTE testing, didn't do much about like OTA testing. Normally we go through the cable connection, but you know our device is getting smaller and smaller, so people tend to use printed antenna or antenna on the chips to reduce the size of the devices. That's why everything has to be done through the air because there's no RF connector anymore. So in this video, we are going to show you some of the simplest OTA testing we set up, and we are going to talk about different solutions using power meters or spectral analyzers. We are going to talk about the pros and the cons between them. Let's get into it now.
The first solution is to use the parameter to do the measurement. I'm using the Transcom handheld vector signal generator to generate the 5G signal, and I'm using the CER parameter to receive it through the air. So I'm getting closer, and you can see the reading from the parameter is getting stronger, pretty much minus 18 dBm. And if I go get away from the horn antenna, is getting smaller. In this way, we can verify the performance of my horn antenna. In the next setup, we use the spectral analyzer to receive the signal. It's a Transcom handheld vector signal analyzer, which can do both the spectral analysis and the demodulation. I think we mentioned this unit before in the previous videos. As I move my RF signal generator, you can see the change of the spectrum. This nice little unit has an excellent sensitivity, which is even better than some of the Keysight or Rohde & Schwarz benchtop spectral analyzer. If you move away from the antenna, you can see the power reduced by more than 20 dB. The test result is pretty much matching the formula we use to calculate the free space transmission loss. Free space loss is 32 dB plus 20 times the log the distance plus 20 times log the frequency. Now we are setting the frequency to 5 gig, and you can imagine the loss will be even higher if we go to millimeter wave. So some people will ask why I need a power meter if a spectral analyzer is much better. So the answer is the cost and the dimension of the unit. You can easily buy a 40 gigahertz power meter with $9,000 CER1. But if you want to buy a 40 gigahertz spectral analyzer, it may cost you more than 69,000 for a CER1. If you need a Keysight brand or Rohde & Schwarz brand, the price may be doubled as well. And the dimension as well, you can easily put a power meter in your pocket and plug in with the USB through your computer. But spectral analyzer is heavy to move and not easy to set up. And of course, you will get more information from the spectral analyzer, especially the spectral information, and you can even do the demodulation, and you can test the EVM, you can see the constellation, you can see the ACPR, so on and so forth. That's so much for today. Today we did the simplest OTA testing with a power meter and the spectral analyzer, and I'm going to talk about the difference between spectral analyzer. I'm going to bring in one of the most expensive spectral analyzer in the world, pretty much $500,000 to compare with some entry-level spectral analyzer. So that will be very interesting in the next video. Thanks for watching this video, and see you next time.